Hey, this is Dr. Ben. Here's two more equilibrium problems. When 4 moles of each of X and Y are placed in a 1-liter vessel, thus rendering them as 4 molar for each, those would be your initial conditions, and they're allowed to react, you find that it forms 6 moles of Z, so the concentration of Z will be 6 mole per liter. Since this goes up from 0 to 6, these will each go down by 3 by virtue of the 2 to 1 ratio, making the final concentrations 3 for X and 4 minus 3, so 1 for X and 1 molar for Y, 6 molar for Z. We'll have KEQ equal to Z squared, which is 6 squared over 1 times 1. I believe our answer is going to be 36. Let's do it using a nice table. You're given that the initial concentrations, now moles and molarity are interchangeable here since it is 1 liter, so you could just cross that out and write molarity, which would be fine. And that is 4 molar for that, 4 molar for that, 0 molar for that. This, they're given that it goes to 6, and it did start at nothing because it was initial to equilibrium. So it went up by 6. These each must go down by 3, being reactants, and only half of the number of molecules react. So we have final values of 1 molar, 1 molar, and 6 molar. Plugging into the equilibrium constant expression, don't forget to square it. That should be an exponent, is 6 squared, which is 36, a nice, healthy equilibrium constant. Now, at this reaction, we're making some hydriodic acid, and it's pretty hot. And they give you the value of K sub C. It's 50. But they also give you all the concentrations. And moles and molarity are interchangeable here since it's 2 moles for every 1 liter. So as given, it's going to be equal to HI is 2 each, right? So it'll be 2 squared over 2 times 2. That's 4 over 4. I believe your the observed equilibrium is simply equal to 1, but it's supposed to be 50. Oh my God, it's going to shift way to the right if our analysis is correct. So it's going to form HI. More HI will form. Reading it completely, will the pressure decrease? The pressure is a wash because 2 molecules form 2 molecules, so the number of particles hitting the flask before, during, and after the reaction is the same. The pressure in this vessel should not change as long as the temperature remains constant, and there will be a net reaction. So I like B. We did have 2 squared over 2 times 2. This looks incorrect to me, right? That's 4 over 4. This should be 1, but regardless, it's way less than 50. Since it's much less than 50, it'll change, and the answer is B. This is 2 more equilibrium problems.